And homework 1 is the Pythagorean theorem, special right triangles, and trig functions. So this first one, finding the missing length, we're going to do this one using the Pythagorean theorem because there are no angles mentioned on there at all, so you know it's not a special triangle. So this x is the hypotenuse. So you would set up the Pythagorean theorem, and the x would go in the spot that that designates the hypotenuse. So you would have a squared plus b squared equals x squared. So that goes in the hypotenuse spot. This one does not go in the hypotenuse spot, so make sure you're careful. So 14 squared, we've got 196 plus 100 equals x squared. So this adds up to 296. And then to solve for x, you take the square root of both sides. So 296, you can divide out a 4. So it ends up being 4 times 74. So square root of 4 is 2, and then there is a 74 left over. So that would be the first one using the Pythagorean theorem. These ones are special triangles, so we'll go with number 3 here. So 45, 45, 90, remember the two legs are the same, and then the y value is root 2 times the legs. All right, so these ones, x is easy because x is the same as the leg that was already labeled on there. So that one's super easy in your 45, 45, 90 triangles. And then y is the leg that you have already, and then times the square root of 2. All right, so the hypotenuse is always root 2 times the dimension of the legs. So we can multiply the square roots, we get the square root of 20, and then 20 can break down to 4 and 5. So the square root of 4 is 2. Which multiplies by the 2 that was already out there, and then there is a 4 left behind. a 5 left behind. All right, let's do, so 7, 8, 9, and 10 are these trig function ones. Let's actually do number 9, because that one is a little bit trickier, figuring out how to use a given ratio. Well, that's weird. There is nothing labeled on there. There's supposed to be triangles on there. All right, so I'll make sure you guys copy these down in class. All right, so this we've got the angle theta down here. This is a 4. This is a 5. Oops. Oh, there we go. Sorry. Oh my goodness. So this is the given ratio for tangent. So those are the two that we are going to label so far. So tangent, remember, is opposite over adjacent. So the opposite to theta would be 4. So that is the 4 that we just labeled over here. The 5 is the adjacent. So that would be the 5 is this dimension right here. So we need to use Pythagorean theorem to find the third dimension, which in this case, the missing one is the hypotenuse. So we would say a squared plus b squared equals c squared, or you can put x squared, whatever you feel like writing here. So this is 16 plus 25 is equal to x squared. So when I add those together, I get 41. And then the square root, 41 doesn't have any perfect square divisors, so you actually just leave this as the square root of 41. All right, so we have our 6 trig functions. The very easiest one to find is cotangent, because remember that's just the reciprocal of tangent, so we can do that. Sine is the opposite over the hypotenuse, so 4 over the square root of 41. So for a bunch of these, we're going to end up rationalizing the denominator. So you multiply by root 41 over root 41. So when you multiply this by root 41, and when you multiply this by root 41, you just get 41. This is the reciprocal of this, so flip the unrationalized version, and it'll be nice and easy. Cosine is adjacent over hypotenuse, so the adjacent is 5, the hypotenuse is root 41, and we're going to rationalize this one the exact same way that we rationalize the one above it, and we end up with this. And then secant is the reciprocal of this, so flip the unrationalized version. So it flips to this. All right, and then we've got some different exact ratios down here. So let's do number 14. 14 is the cotangent of 60 degrees. So cotangent is the reciprocal of tangent, so it is the adjacent side over the opposite side. And if you guys were to look at our special triangles, which I'll actually just sketch it in down here. So I'll make this a 30, 60, 90. Okay, so here's what we know. We've got the shortest side across from the 30-degree angle. The hypotenuse is double the shortest side, and then our second leg, the longer of the two legs, is root 3 times the short side. So you've got that ratio going on for every 30, 60, 90 triangle. So if we want the cotangent of 60 degrees, cotangent would be the adjacent side over the opposite side. So the adjacent side over the opposite side. So remember the x's cancel, so we have 1 over root 3. And then because we have that square root, we want to rationalize by multiplying by root 3 over root 3. So we get a root 3 in the numerator and then just a plain old 3 in the denominator.